look back. Y equals, keep an eye on what we're doing, x cubed, graph, and we were doing the derivative at 3, trace to 3. Oh, it's way up at 27. So, what we just found, take a quick peek. Here's my cubic equation. When x is 3, that 27 that we found is giving us the rate of change. It's the slope of this tangent line here. The rise over the run of that new line is going to be 27. So it's the slope of the tangent line that we're finding, the rate of change. Okay, one more. F of x equals 6. Can you find the derivative at 5? Okay, let's take a look at that graph first. Y equals 6. If you didn't know and don't remember, it's just a horizontal line at 6. So y equals 6 looks like this, going through that y value of 6. Okay, and we're going to find the derivative at 5 using the definition. So f prime of 5 is the limit as x approaches 5 of f of x minus f of 6 all over x minus 5, my bad, f of x minus f of 5 all over x minus 5. Now I'll substitute in. F of x, the equation, is just 6. F of 5, well, what is the function value when x is 5? 6 again, all over x minus 5. I'm going to simplify before I substitute in. I'm not substituting in yet. 6 minus 6 is 0. Over x minus 5. Still simplifying. What's 0 divided by anything? What does that simplify to? 0 divided by anything is 0. Now I've got the limit of a constant. What is the limit of a constant? It is the constant. So we got a derivative of 0. Let's think about what that means. The rate of change is 0. So think about it. How fast is the rise over the 1 changing here? Well, because it's flat, there is no slope there. The slope is 0. That's why the derivative is coming out at 0. So any constant function is going to have a derivative of 0 because they're flat. Okay? And one last thing. I'm going to add an extra step at the end, as soon as I find it. If f of x equals x squared, can you find f prime of 1 and give me the equation of the tangent line at 1? Okay, so the first part is just what we've been doing, using that definition for derivative to get the derivative value. So f prime of 1 equals the limit as x approaches 1 of, and I'll write the definition out, f of x minus f of my c value all over x minus my c value. If you write that down a few times, you won't forget it for the quiz. Not that you have to start there. You could start with this line. So I'll start with my equation, which is only x squared minus f of 1. F of 1 means plug it into the equation. Just happens to be the 1 again. But don't forget to plug it in. Over okay, if I plug in, I'll get 1 minus 1 over 1 minus 1. Tells me I have to factor. This is a quadratic up here, so I don't have to do that long division stuff. X minus 1 here. I know I've got to get the x squared, so there's an x. I know I've got to get a negative 1 here, plus 1. And there's no middle term because the middle term, they cancel out. 1x minus 1x, they're gone. Cancel. Now substitute into what's left. 1 plus 1. So we got a derivative of 2. So how does that now help me find the equation of the tangent line? Let's take a look at what we're actually finding. So y equals x squared, that's my parabola, vertex at the origin opening upward. At 1, we're at 1. So our goal now is to find the equation of this tangent line. And I know quite a lot about this line. Oops. I know quite a lot about this line right now. I know an ordered pair that's on the line because it shares the ordered pair with that parabola. That point was 1, 1. When x was 1, we plugged it in, the y was 1. So I've got a point on the line. 1, 1. And because I just found this derivative value of 2, I now know the slope of this line also. The slope equals 2. And if I want to write the equation of a line, I've got to know basically two things. Y equals mx plus b. I need to know the slope, and I need to know the y-intercept. Well, I don't know the y-intercept yet. I know the slope, and I know a point. So I can substitute into these three parts and then solve for the b. So y is 1, the slope is 2, and the corresponding x value is also 1. Little algebra. Subtract the 2. B is a negative 1. Now I've got the two things necessary to write the equation of a line. The slope, the y-intercept. So the equation of that tangent line, y equals 2x minus 1. Okay. I wrote your assignment down here. Of course, no page number. Page 82. 1, 2, 5 through 13 odd. I'm also going to add on, because this is just find the derivative with that definition, I also want you to find the equation of the tangent line for all of these. Find equation of tangent line also, besides doing the derivative like it says in the book. 14, and then 19 I'm going to have on a worksheet for you in class. We can go through it together, so don't try that one in your book because it's going to require drawing on the graph. So we'll do this one, most of it in class together. Alright, that's all I got.